We're going to be talking about Docker today. I'm not sure if this is a good idea or a bad idea. I'll let you be the judge of that. I feel like Docker is a great thing to know about, but the amount of hours I spent debugging Docker issues and dealing with weirdies, I don't know if it's worth it. This is maybe counter to what last year I was all about Docker. Now I'm feeling a little different about it, but no, I like it. It's a great tool. You should know about it. I think it's the future of some use cases. So definitely a valuable thing to understand and be familiar with. So definitely do that, but it's not the silver bullet, use it for everything and Dockerize everything. You got to be a little careful with that. So my background with Docker is, I guess I'm self-taught. No formal training by any means. I just thought it was cool and I built it. I do a lot of web services for fun and also for some of my research. And so that's a good fit for it. That's where you really see Docker take off is in the web space. But by no means am I an expert in Docker. So, ask me questions, please, and I'll try to answer them, but I won't know a lot of things necessarily. Docker's huge and I don't use it on a daily basis by any means, so there will be things I don't know, but we'll all learn together. How about that? So who here has heard of Docker? Okay, so most of you have, anyone know what it is? Venture a guess? Yeah. Yeah, some kind of virtual machine. That's a good way of kind of thinking about it. It's some kind of way to containerize your applications, separate into a virtual machine. We'll talk about in a second how it's different than a virtual machine. But I guess for this lecture, I'm not going to be showing you how to use it. I mean, I'll show you a little bit, but go find tutorials or YouTube videos or whatever on actually how to use it. I'll just kind of give you a general overview, like all these lectures have been. So by the end of this, you will not know how to use Docker that much better, but hopefully you have a good understanding of how it all kind of works together and some of the commands and things you got to deal with. So like you described, Docker is a way to kind of separate things out into virtual machines, if you want to call that, or containers, as they're called in Docker. I should say, actually, maybe I didn't plan on this, but Docker was kind of the first big software package to use containers, but now containers has become a construct within Linux itself. And so there's actually other applications out there besides Docker. I'm not familiar with them. I've only used Docker, but there are other things that can help you manage containers. So just be aware of that Docker used to be the only player, but now there's other people that, other programs that can do this as well. So it's important to understand the context behind this first. Like, well, why do we need this? Okay, cool. More virtual machines, more whatever. Why do we need it? So in my opinion, one of the biggest things it's trying to solve is that issue that we all have. I have had it with my students already this summer is, well, it works on my computer. Why doesn't it work on yours? It's like, oh, why is this different? So get rid of that. It's kind of annoying. Sorry. Okay, so why does it work on my machine but not yours? So it'd be really great if we could come up with a standardized way of setting up our machines. So that's what they tried to do with Docker and containers. So when you talk about containers, think of something like this. If you want to ship something across the world, then you have to be able to put it into this container. However densely you can pack this container, more power to you, but it has to fit in there. And why that's important is because if you didn't have it fit in there, then they wouldn't be able to optimally pack up, these cargo ships or these trains or whatever they ship these things in to be something like this. Because they're all standard sizes, they can all just fit together and they can densely pack in and go across from China over to here. So it all starts with this container, though. We all have to have a standardized way of packaging up software or goods that we're trying to ship so that we all can be able to work together on the same goal. And so that's what the purpose of Docker is to put everything in a standard container format and a very clear recipe for how to make that container that then will guarantee, I should put air quotes on a guarantee that it'll work on anyone's computer. And it's not just an annoyance of, oh, it's working on my computer and your computer. This is actually a big issue with enterprise software, right? Because you are running some web service and you have 5, 10, 100 different servers going on, and you need to be able to scale those up. And each of them a slightly different operating system or slightly different hardware. And so it can become a full-time job, in fact, to orchestrate all this and get this all set up. Okay, well, there's a bug fix I need So how do I deploy this in certain ways? And so Docker is trying to help with that in terms of standardizing all this. Any questions so far on that? Okay. Let me see here what I was going to say. So yeah, so what is Docker? It's like a VM, but it's lighter weight. So I imagine you can only have a few amount of VMs on your computer at one time, right? I mean, I've never tried to open more than one VM. Anyone tried to do more than one VM? How many have you got? I mean, two?
Oh, I've had two open, and yeah, they bog down.
Yeah, they bog down. So I mean, I would say the VMs, I mean, it depends on your computer, but you're on the order of tens of VMs you could probably have concurrently going on, or maybe even single digit. Whereas Docker, you can have much more than that, hundreds, probably not thousands, but hundreds of these containers. Depends on what's running on the containers, and once again depends on your computer. But a lot more, so it's much lighter weight. Whereas a VM, it lets you have essentially different hardware. It virtualizes the hardware, so you can say, oh, give this VM one of my virtual cores, or a couple of them, or how much RAM you want to give. Docker does not do that. It just uses the hardware that you have on your computer. So it's up higher layer in the stack in terms of it's just virtualizing the software and not the hardware. So it's not as isolated as a VM, whereas a VM, you can have a whole completely independent operating system running on there, like Linux running Windows. It's not quite that isolated with Docker, but you get the benefit of it's much lighter weight. You're sharing at the file system layer. It uses a layered file system, which might not mean anything to you, and that's okay. You'll kind of see that happen here, but how Docker is set up is it's got these different layers to it. And so you can actually build Docker images on top of Docker images on top of Docker images, and it's all kind of works, these different layers of it. And I'll try to point that out when we actually go through some of these things of what that looks like. And that has some nice benefits of composing and having different base images. So I would say Docker is great. There's still reasons to use VMs. You want to run Windows on your Mac, then you got to use a VM, most likely. So there's still definitely room for VMs, but I think Docker is a great thing to consider if you want a lightweight approach to kind of standardize and compartmentalize a piece of software. Okay. Any questions on that? Yeah.
Your last comment, you need a VM to run Windows on a Mac.
Don't you?
Yeah,
Okay.
but you don't need a VM to run Linux on a Mac because Docker will do it.
That's fair.
What's the distinction there?
I think it's where the hardware emulation comes in is. So yeah, it's emulating the hardware. So if you looked at your system configuration on Docker, it'd say you have X amount of CPUs, it'd be the same that's running on your host machine. Whereas with a VM, it'd say, oh, whatever you designated for that VM to have. So it's emulated at the hardware level.
Okay, but why does Windows need a VM? Is it just fundamental under the hood differences?
Yeah, I think the driver system, I don't know exactly.
Okay, probably, okay.
If someone has,
Topic.
yeah, no, that's a good point. Yeah. And there's other reasons to use Docker containers, I'd say too. I would say one of them is that it's nice to kind of just keep everything separate. I often will just bring up like Ubuntu on my computer just because I want to test out some commands, and I can just like delete it, and then it's as if it didn't exist. And so you won't mess up your computer. Dr. Nelson mentioned if you mess up your Python version, right, of your system Python, you can really hurt your computer. Docker, you just create a Docker container and just delete it, and it's fine. So you don't mess up your computer if you use Docker. That's a nice benefit of it. There's also security. This isn't a huge issue. Maybe for stuff like that we do, but for web apps, that's a big issue is it gives you another layer of isolation so that if a person does break into your web app, they're only within this Docker environment. And so they can't, in theory, get to your host computer and take over and get like sudo privileges and stuff like that. I don't know if I'm going to do it this year, but I actually had a challenge for my senior level networking class. I had a web service running, and if they could break into it and take control of my computer, my VM, then I would give them extra credit. So I was fairly confident. I got a little nervous near the end, but I was fairly confident because it was running in a Docker container. And so I'm like, okay, even if they do hack into my web app, at least they'll only have access to my Docker container. So it gives you an extra kind of level of security there. Okay, terminology. I've already said some of these things, but Docker has some interesting terminology. So there's Docker containers, That's what's running currently on your computer is a Docker container. The images are the recipe to make that container happen. So there's images, there's containers. I'll try to use those carefully, but at times I get them mixed up and just call them all containers. But an image is essentially a recipe, and then when you create that recipe, then it becomes a container on a computer. And the last thing, it's very important to keep track of the host computer. That's this computer right here. There's a container, and that has its own kind of operating system, essentially, in a way. And then there's the host computer. And you got to have a very good mental model of the difference between those things, or else it'll bite you. And I'll show you a demo where it does kind of get you. You have to say, wait, why didn't this work? Oh, it's because I'm talking to the inside a container, not to my host. Okay, any questions? Because if not, let's get like actually typing and show you some stuff. Yes. Yes. So there's a couple of ways. Yeah, we'll get into some of them. So you can mount a volume, it's called. So then you can share file system stuff. There's also, if you know what you're doing, you can set up a privileged Docker container, and that kind of ruins the security benefits of it. Essentially, it gives you more access to do things on your computer. So you need to often do that if you want the Docker container to deal with hardware. Then you need to usually set up to privilege so that it has more access to the hardware. Yeah. No. I mean, it takes up a little space to install all this stuff, but yeah, it doesn't take up any extra. It's just, yeah, it doesn't have this big, what do they call it, like the virtual disks, you know, yeah, no, it doesn't have anything like that. Good point. Okay, cool. Docker, so that's command. So it's running as a daemon on my computer. You can see it for a Mac, there's a little symbol right there. That means it's running. But there's a command line tool for how to interact with it. It's I don't even know all these commands. There's quite a big utility, you know, in terms of all the different things. I'll show you what I use often. So there's Docker PS. That'll show you all the containers that are currently running. Is that too low? Should I raise this up, or can you see it all right? Bigger? Okay. Oh, that's wrong. Okay. I don't know if that was that much bigger. Okay. Docker PS here. Let me. Okay. Docker PS. Okay. So more commands so far. So let's actually do something with this. Do run Ubuntu. Okay. So I'm gonna run this command, and a lot of things are going to happen at once. If the Wi-Fi is working properly, it should all work. Okay. So first, okay, let's let it do its thing. I'll describe what's happening. First, it's saying, hey, run Ubuntu. It's like, I don't know what Ubuntu is. So what I'm providing is say, hey, Docker, this is a subcommand run, and then the image name, Ubuntu in this case. It's like, well, Ubuntu, I don't know what it is. So then it'll go off to some kind of repository. Docker Hub is the default one, could be other ones, and say, well, where is Ubuntu? And then it pulls it down. That's kind of interesting. If it's a colon latest, this is some weird idea of Docker, or just a convention of Docker, that it's colon and then a tag name. So it's the image colon tag. If you don't specify a tag, which I didn't in this case, it defaults to latest. That's a convention, kind of like, Git is master or main branch. Those are just names, same thing. Latest is just a name, but that's what usually, what people use is the latest for the latest version of that image. Okay, so I'm going to go out to the internet. I'm going to find this image they call Ubuntu. I mean, I could type in, I don't know, I want to be a little careful. Let's just misspell it. And it's going to look for it and say, oh, I can't find it. Okay. So that's where, if that image didn't exist, then it would not know what to do with it. It can be an error. But this image does exist. So then it downloads it. And so you saw a couple things happening. It pulls it. So this is where we see the layers of the file system here. It pulls down this layer first and extracts it. It pulls down this layer, has it downloaded from the internet, and then it extracts them and then runs it. So here we see that Ubuntu layer, this Ubuntu image is actually made of 3 separate layers that make it all work together. Okay, so let's do it again. That's only you only have to do that once, and it's locally on your computer now. So let's run it again. Okay, so this time it did give me a warning saying, hey, because it knows where it is. It's locally on a machine. So hit run and it doesn't really do anything. It's kind of a boring command. It essentially created a container in the background and then ran the default command for Ubuntu, which you specify, and I'll show you later in a Dockerfile. So there's some default command for each image. And I guess the default command is to do nothing and it closes itself out. So really boring command. Let's do something a little more. You can specify what the command is to override the default. So you're saying Docker run image name and then the command you want to run. Then, but before you do that, you have to put, tell it, I want to interact with this container. That's not the standard for Docker. You usually don't interact with them, but you can if you want to. So you have to put the I for interactive and the T for open up a terminal. And then it's going to execute bin/bash for me. So it's going to bring up a bash shell. Okay. So here, my terminal style has changed. So now you know I'm in the container. Oops. Oh, I just closed out of it. Okay, let's bring it back up. Okay. So I can do ls. I can see that's not Mac. You know, that's definitely Linux. You see the different Linuxy kind of things. We can do whatever we want here. Now I'm in Linux world. I'm in Ubuntu. I'm in a container. I could delete the whole file system if I want to. I don't want to tempt fate, so I'm not going to do that right now, but I'm 99.99% confident that it would not delete everything on my computer, just just the container, but you know, once again, don't tempt fate, especially in a demo. So I could delete everything. I can move things around. I can do whatever I want. I mean, I can explore. I mean, let me prove to you maybe, find what the right command is. What's that? I could, yeah, let's do that. So I could run cat os release to see. Oops, spelled that wrong. Sure enough, it says I'm in Ubuntu 20.4. Right, that's the latest version, right? Okay, I could do apt update. What, apt on a Mac? No way. So yeah, because we're in Linux, so I apt update. Now I will tell you that Docker, to keep everything really small, has like no packages in it at all by default. I mean, like, don't they always come with nano at least? No nano, like nothing. So let's install apt get apt install vim, the true. Okay, so then it'll install all that stuff for us, sure. So anything else you want to see within this Linux container I'm doing? I want to prove that it's Linux. All looks Linuxy, right? It's even though I'm in the container right now, running Linux. I don't know what all these warnings are. That's concerning. But that. Okay, so let's close out of this. So now I just left the container. And let's do Docker PS. So nothing's running right now. Okay, that makes sense. I closed out of it. But let's bring up all. It actually keeps these containers around. These are my failed attempts. Let's see, which one did I just close out of 11 seconds ago? So there it is. It gives you a default name of some two random words put together. You can name it yourself, of course, if you want to. So there's our containers that we created, and they actually stick around. So we could say, well, let's bring it back up. Docker start, Brave, okay. Start. Okay, so it started. Now remember, it's meant to be separate. I had to kind of give it special instructions to bring it into bash and interact with it. So its default kind of state is not to be interacted with. That's typically how you want to run Docker containers. It's let it kind of do its own thing. Rarely, unless you're like debugging, do you actually want to interact with it on a terminal. But let's make sure it's running. PS. Okay, there it is. It's been up for 20 seconds. Cool. So how do I get back into it now? Because if I hit run, type in run, it'll create a new instance. So there's Docker exec. The old one. This is my practice run. Okay, now I'm back in it. Is Vim here? Yep, Vim's here. So that proves it's the right one. I can go test txt. Let's create a little file there. So you see it right here. We'll go out of there. Docker PS is still running in the background. I could then do Docker stop, give it the name. So you can do kind of all the things you would expect to do: start, stop, stuff like that. And there it is. Okay, so there, it's sitting there. not running. So yeah, so that's Docker kind of in terms of starting and stopping. But this is not really how you want to use Docker. I mean, sometimes you need to start and stop, but you really want to treat these as there's a word for it. I just don't know what it is. I can't think of it off my head. Word disposable, I guess, but there's a cooler word for it. But you want to treat Docker containers as disposable. You often don't want to leave them around on your machine to start and stop them whenever you please, creating files, because they're meant to be disposable. And so anything that you want to save on that Docker image or container, you want it somewhere else, not including just in the container. So it's such a common practice with Docker that actually there's a special command line tool for that, option, --rm. So what this will do is bring up a container, execute this command, in which this case this command is interactive. When I close out of it and the exit, the bash exits, then deletes that container for me. Let's run that, echo test, we run a command, you leave it, and there it's gone. There's nothing that's, this was the one I just exited, but yeah, so now it's not there. So I almost like run --rm, almost 100% of the time, unless I know I'm going to keep it around, but because you just want to assume that they're disposable. It's a good practice, because what would be the worst thing is you write all your special files inside the container, and then you go later on and you forget that you wrote all these special files in the container and you delete it, and then they're all gone. So you want to almost just by default treat them as disposable, and they're going to be gone as soon as you finish your command. Okay, so far not that useful. I mean, though actually I think running Ubuntu is somewhat useful, because sometimes I'm like, Mac has slightly different versions of things than Ubuntu does, and I want the Ubuntu version, so I'll quickly bring up Ubuntu and start typing away these commands, say, okay, that's what the right command is for Linux. Okay, but let's do a little bit more interesting stuff. Let's run Python. So what we're saying here is run Python, and I'm going to run the 3.9 tag, version 3.9. I don't have that image. Just going to go ahead and download it for me. This is what I'm worried about with the demos, because I actually wiped away all my cache. This is all cache, but just to show you, I wiped it all clean. So it could take a while for some images, but hopefully it'll be quick. Let's see. While we're doing that, can I bring up this one? No, it's too small. Let's wait for it to finish. Okay, there it's done. I didn't provide what command to run, so we use the default command. And what you'd expect Python's default command to be is to run Python. So now I'm in a REPL. Sure enough, I have 3.9.5. I specified the 3.9 and just gave me the latest version of 3.9. Great. So now I'm in Python world. I can type in, no, not that. Type in whatever I want. So that's useful in itself. To be able to just bring up a quick Python and try that out. And now it's just disappeared. What was that?
It didn't just run Python on your machine though. It created we've got an image right there.
Yeah, I got the whole image. I mean, got the whole infrastructure to run Python for you. So yeah, it's not just the Python executable. Is that what you're saying?
Yeah.
I got a whole container, to run that in.
But what was that container based on? Was it like
That's a good question. Yes, what is it based on? So we'll get to that. Let me show a few more things related to the Python, and then yeah. So I mean, because this is useful, but what if you don't want to REPL? What if you want to just like run a file, maybe? So how do you do that? I just do, okay, here I could default in Python, and then here I have this demo.py. Oh, so wait, but my demo is right there. If I do ls, demo.py, where are you? Oh, yeah, right there. Sorry, it's hiding. Demo.py. So it is there. So why didn't it find it? Anyone know why? Yeah.
not in the container?
It's not in the container. Yep. This command is having inside the container, but my file is outside of the container. So to answer someone's question is, so how do you do that? How do you communicate? So what you can set up is a volume, --v, and then you have to do the actual full path for what host folder you want to synchronize with the container folder. standard convention is if you want to do the present, current working directory, present working directory, then you just do that. People are familiar with that, right? That's a bash variable for what your current present working directory is. And why people do that instead of the dot is because it has to be, for some reason, it has to be an absolute path. It can't be a relative path. Dot is a relative path. And so, yeah, that's often what people put. So let's do slash code. Okay, still didn't work. So what we're doing is we're synchronizing the current directory I'm in, docker.intro, into slash code. This is a common convention in Docker to always just go based on the root. I'm not sure why. I think why bother dealing with more slashes when you don't need to, if it's just going to disappear anyways. So let's kind of see what's going on here. So instead of running Python, I'm going to just do bin/bash. Okay, so now we're in here and we see slash code. Great. CD code, go into there. Okay, there's all my files. Awesome. Warning, volume is synchronized both ways. So in this case, I would not want to delete all the folders in that file, files in the folder, because it would delete all of them on my host. I do, touch temp.txt. Where are you? Code. Temp.txt, it's right there. If I remove it, it's gone. So now they're synchronized. So you got to be careful now. It's not quite disposable anymore. I mean, it is, but you have a sync point that you got to be a little careful about. Okay, so let's go back out of that and let's actually run it now. So Python, it now has to be /code demo. Awesome. I just think that's amazing what's happening. This one command, I mean, it's a little cumbersome. Of course, you can make a nice alias, but what's happening is it's bringing up a Docker container, it's running Python, and then it's destroying it. I just think that's amazing what's happening almost instantaneously, almost as fast as Python itself running it. Not quite as fast, but yeah, isn't that cool? It gets me excited. I don't think it gets you guys excited yet. Okay. Let's see here. So yes, what Dr. Mingleson said, okay, Python 3.9, great, but what is going on there? Yeah, it's not like it's just executable. It's much more than that. Let's see where did this Python image come from? Let's do Docker Python. Someone spelled it wrong. So it didn't work good. So Docker Hub is where Docker hosts all these images, and you can upload your own images too if you want there. So here's the official Python images. Go through here. So remember those tags. Anything after the colon is a tag. Got a lot of different tags here. This is a common convention, for Docker. So what this is trying to tell us, and it's confusing, and some people do it wrong or have different conventions. Trying to say after the colon, you can choose what version of Python you want, 3.6.13. I think it's only giving you the last dot. I could choose 3.6, 3.7. And then it's doing a dash, and it's telling you what base image it's using. It's using, for example, this Alpine. It's using Alpine Linux 3.13 there. The Buster is for Debian version Buster. You can use Stretch if you want to use Stretch for some reason, the older version. So essentially all these different combinations, of course, and then they have a slim version of Buster. So you can, essentially you're choosing what Python version, but you're also choosing what base image the Python version is using. And then there's these share tags. So when I do 3.9, what I'm really saying is I could have done 3, but when I'm saying 3.9, I'm actually saying 3.9.5, which actually is saying 3.95.buster. Click on that. And this will show us a Docker file, and we'll get to that in a second. Actually write our own. But this is essentially a make file for Docker. It's the recipe we need to make this image. And it's a lot of magic here, so I'm not going into details, but the part you'll be most interested in is right here. These are commands you've seen run maybe in your life, a wget to download a certain version of Python. and then you remove stuff, make directories. Eventually, you're going to configure, and you're going to make, and then you're going to make install. So what it's doing for us, or someone did in the past, is they created this recipe for us of how to install Python on top of Buster or a Stretch or whatever base image we wanted here. They took care of all the instructions to do that. And then what Docker is doing is took all those layers of the file system and just hosting it somewhere. And when we want them, we just download them to our computer. So we're not actually running these commands. They're already cached, already been run for us. We're just downloading the result of those commands, what it did to the file system essentially to make it all possible. So a lot of, there's some good stuff in here, but there's also kind of some weird specific Docker stuff to make it kind of Dockery. Thing I want to show is Docker images. So just give us a feel for it. So for example, Docker, how big the Python 3.9 Docker image is, it's almost a gigabyte. So maybe that gives more meaning for what it means by dash slim. If you want the slim version, then maybe let's try doing that. Let's do Python dash slim. Let's see the size difference. I don't care about that. Okay, where are we at? So a lot smaller, 8 times smaller. But sometimes you want to have full image because you maybe want to use Python's as your base image. And I'll show that in a little bit. Any questions on this so far, or anything I missed? Does that answer your question, Dr. Nicholson? Is that what you're trying to get at? So it's this complex layering system. I mean, what's their base image? Oh, it's the build pack -devs -buster. And this is where it gets kind of magical. And if you look that up, there'd be a lot of weird kind of special Docker commands going on there. This is where the layering is happening. Now we can depend on Python 3.9. And then if we write a utility, then someone could depend on that utility or that image. Yeah. It can do GUI apps. There has to be kind of some special magic to make that possible of synchronizing, like sharing volumes and putting in privilege mode. I tend to stay away from that because it just seems a little too magical for me, but it is possible.
So one thing you can do is Docker can host a web service, and then you can go to a website in your browser, and that's really easy.
Yes, I would say that's the preferred approach is using the internet, using the web, networking. It's important stuff, and we'll get to that in a second of why I feel like that's the best fit for Docker is using actually web standards for anything with this stuff. Any questions on this so far? Is this all making sense? Kind of these pieces hopefully coming together. Why you might want to investigate more into Docker? Well, I mean, let's get a little crazier. I mean, just for the heck of it, let's say 10 dot, is it 0.b1? I know it's, but it's too lazy to look. Okay. Let's install a beta version of Python. See what that's all about. Try it out. I had to look. We can do. This is a Python 3.10 specific command. I actually thought kind of interesting. It'll count how many 1 bits are in your number. Kind of cool. So 8. Has only 1. That's specific to 3. That's to prove that this is 3.10. Let's just. Oh, that's not even. Fast. Okay, there's 26 ones in that giant number. There you go. So when you get 3.10, now you can count all your ones. It's got to help you in some assignment. But it's not just Python. I mean, so this is, I guess, why I joked when we talked about the Python environments. Just sidestep that whole issue of PyEnv and all these things, and just use Docker because it's just so quick. Just bring up a new instance of Docker and be able to work on whatever version you want to, and it's completely separate. There's no files littering your file system. There actually is, but it's all inside a Docker kind of environment. So this is a viable alternative to dealing with the Python virtual environment issue because it's just completely separate. Okay. Let's see. Just any Node fans out there? No Node.js? No? Okay. We can pull down, no. Okay, notice that some of these already exist because they're using some of the same base layers as other ones. I don't know which ones they are, but let's assume Python. They have the same base images, so it's already cached on my computer. So that's a nice benefit. So now I didn't give it a command, so I just gave me the default command, and I'm in Node.js. You can tell you're in JavaScript because the empty list plus empty list is an empty string. Why? I don't know. It's like a really bad idea. You guys have you seen that WTF.js? Look it up. There's all these weirdities about JavaScript, and because it was like written in a day and it's got some weird nuances to it. That's one of them. Two empty lists equals an empty string. Okay. Now, this is nothing I've used a lot, but it's worth talking about because it's maybe the new age thing to do. Is typing out these commands and figuring out all these things is kind of annoying, right? So let's get a GUI, and this actually will give us a good example of what Docker, how powerful Docker is. This thing called portainer. I actually never said it out loud, so I hope I'm saying that right. Sometimes you just see things written down, and there we go. Okay, this is a web app that is meant to manage your Docker for you. Give you these nice little commands to run. So let me just run these commands for you. Create a volume. If you don't want to synchronize your file system, you can actually create a volume in Docker. We won't get into that, but it's a nice feature. If you need it, you need it. And then let's just copy this whole thing. Yeah, there's a lot going on there. Don't worry about it. But it's just setting up a lot of shared things. Okay, so it's downloading it, running it. Okay, one thing I will say, where are you? -D, detach. I haven't set that up yet. So what that does is it's going to create that Docker container and it's going to detach me from it, which is often actually what you want. So it's Docker, yes. So it is running there. It's been up for 11 seconds, but I don't see it. It's not blocking my terminal. Okay, and then like Dr. Mingleson said, we go to the appropriate host port 9000 appropriate website. There you go. Now we've got this beautiful web app. Oh no, what's going on here? Okay, it usually asks you to create a username and password. I'm not sure.
You have the volume.
I guess I do. Oh, wow, good. I remember my password. I just kind of made up. So it is actually really fancy. I mean, I'm impressed with it. So here it's hooked up with my Docker local, and you could hook it. Docker actually access from a whole separate computer. I can see all the different images I have right here, all the kind of stuff I've been playing with. I can go ahead and say, oh, let me just remove one. It's taking up space. Where's that Python? Node. Look at Node. It's almost taking up a gigabyte. No, thank you. Let's delete you. Okay, now it's gone. So I could have run the corresponding Docker RM command, but it's just nice, to do it here visually, and you can look at containers and see what's starting and stopped. We can bring things back up. There's app templates. Oh, let me run MySQL server. Bam, you hit that, and then it just starts it up for you in theory. Once again, I don't have actually tons of experience with this, but this is often what people tell you to do. Install Docker and then install this tool next, because then it just kind of makes things easier for you. Yeah, any questions on this? And to me, that's kind of amazing that I didn't have to do apt-get, or if you're familiar with Macs, a brew install and check out dependencies. And say, oh, dang it, Python is the wrong version. It's just one Docker command, and it just took care of that all for me. It encapsulated all the different dependencies I would need on my computer. And I didn't have to deal with that. I just downloaded essentially the different file system layers and then just ran them. So something complicated like this can just be simplified to one command. So actually, often not that easy, but okay. Are you convinced yet to look at Docker? Okay, I see a little bit of nod. Thank you. Appreciate someone. Okay, well, let's actually build our own app now. Let's see how we actually do some development. So far, we're using other people's stuff, and I mean, oh, dang it, I just thought of a good one. Docker Pi-hole. Anyone use Pi-hole? Heard of Pi-hole? Very good, Pi-hole. Pi-hole is something you run on a computer on on a Raspberry Pi typically. It can be run on anything you want, but typically it's run on a Raspberry Pi. That will block ads on your network. It essentially pretends to be a DNS server, and then it blocks ads. And so sure enough, someone's written it for Docker. So in theory, okay, it's not that. But you run some commands in Docker and then it just appears. And so this is a good example of something you can do with Docker. Okay. So let's run our own app now. Let's see here. Okay, let me show you my code first. And just to come full circle, write a CSV parser. Okay, so here's my CSV parser. Parsing the CSV code's not that important, but it's doing what we had asked you to do previously. So to create our own image, we actually don't have to do this. This is a little heavy-handed, as you'll see in a second, but just for the sake of kind of exposing you to things, we're creating our own specialized image. So we could have just used Python 3.9 or Python 3.8 by default, but let's create our own image. Our image is really simple. All it does is depends on 3.9. I chose that arbitrarily. I mean, I just like to use the most recent version of Python.
Make the text bigger.
Oh, yeah, sorry, thank you.
On the back row.
Sorry, guys. Is that okay? You want me to go for longer? I was confused. Is that usually stretch it out? Okay, so all I'm doing is, I don't even have to really do this, but I'm saying create a folder in my container called app. That's gonna be my and then everything's gonna be based on that, and then copy everything from my host. For some reason you can do relative path there. Everything in this folder right here into that folder. And take all this code and put it into my container. So let's do that. Okay. So let's do Docker. So this is a new command. We need to build it. We build this image, and it's going to use this Dockerfile, kind of like a make file, to build it for us. You have to give it a name. -t is you have to tag it for a name. So I could put demo-_1 : latest, but I'm not going to do that. It's going to do it for me. And then build everything inside this folder. That's what the dot's for. Inside this folder I'm currently in. So look for a Dockerfile and then run it. Okay, there, it's done. It's built. It's pretty quick. I mean, you kind of see all the things it's doing here. Most of it, the important thing right here is it's going line by line through my Dockerfile and running them for me. Each one of those commands. These are really simple commands, so they're almost instantaneous. You run it again. You'll see now what it's saying is, well, now they're cached. So actually, he was able to cache it. That's actually a huge benefit. And it's trying to install this huge package, can actually cache different intermediate layers, which is really helpful. So there actually did the work. Here it's just saying, well, nothing's changed, so I can just use the cached version of it. Okay, great. So now I have a Docker container, a Docker image called demo_1 that now has my code inside of it. So let's run that, Docker run. Find it. Okay, demo. Okay, now in my Docker file, I didn't actually specify a default command. The next example I'll show you where it is specified. So it's using Python 3.9's default command, so which is to run Python. Okay, so that's not what I want. So run Python. What do I call this? CSV parser. Okay, so it's running it. Great. So let's get my demo here. So example data. And then it works. Okay, -c, okay, I can take whatever columns I want. Okay, great. So it works. Any questions on that? Okay, there's a little bit of subtlety here in that because my example data is inside this folder, it got copied into the Docker container. If I want to execute somewhere else, let's say I have my CSV file maybe back a directory. I don't, but let's say I did. It would not, remember, this is all relative to the container. So it'd say, okay, I'm gonna go back a directory inside my container and run it. So you gotta be a little careful about that. So what you would really wanna do is actually set up a volume. So this is a long way of saying that this is actually not that useful, because if I wanted to choose arbitrary, I mean, let's choose one. Let's go back. Python tutorial, and then where are we? Example data. If I want to do that, well, I can't do that because it doesn't know this is on my host computer, right? But it's executing that command from my container. So how do I, so I have to copy the folder, those files into a certain folder, or I have to set up a volume like I showed you before, dash V, and then find, copy this, get the directory of this folder, and then synchronize it. It's all mess. So this is a long way of saying that this is not a case where Docker fits well. A command line tool, in my opinion, is not a very good option for Docker, because Docker, right, one of its purposes is to isolate, keep everything separate. But a command line interface tool is meant to interact with your computer, not to be isolated, right? So that's not really a good match. If you want something that, you're isolating it just to have to do all this work to not isolate it. So I wanted to show you this because it's something you hope you're familiar with if you did your homework. But I would say this is typically not a good idea. There are ways to make this easier. You can set up an alias or like some kind of quick function, to automatically sync that volume, sync the directory you're currently in. But honestly, it's not a great idea. Okay. So in my opinion, what would be a good fit for something like this is more of like a web app, something where you're interacting with beyond the file system, something kind of higher layer than the file system itself. So like with HTTP. So let me show you that. So that's demo 2. Any questions while I'm preparing for demo 2? Okay. And this is more complicated of an app. So this will be a little more interesting than the other ones. So first, here is the code. I'm using a library, this web app using a library called Flask. Python, you don't even know anything about it, but it's a good thing to know if you are into Python and want to do web apps. I'm also using pandas, matplotlib. I want to bring in all these different lectures and just go crazy with it. So it's going to take a CSV file. I've only run this once, so cross your fingers. But what I'm going to do is I'm going to take a file. I'm going to say, hey, I'm going to bring up a web page. You're going to upload a file, and it's going to convert it. Oh, no, it's actually going to graph it for you. That's the idea here. That's what this code right here is doing. Once again, you don't have to know what this code is, but maybe you're familiar with this. This is pandas reading in a CSV file. I'm telling it what the index is, and then I'm going to get the temperature in Fahrenheit and plot it. I have to do some extra work here to say don't write to a file, actually write to a buffer, and I'm going to send that buffer across HTTP to my web browser. It's going to display the image. So the code does, let's look at what the Dockerfile does. This is a little more interesting here because we're actually running commands. So same base image, same worker is what I meant. But now we're doing something more interesting here. We're copying requirements.txt. Anyone familiar with requirements.txt? You guys hopefully seen that before, maybe not. It's kind of just the way pip encapsulates what dependencies are in an environment. So you do like pip freeze and you pipe it to requirements.txt. So those are my requirements. Usually actually puts the version number, but I actually handcrafted this. So I don't know, what I'm talking usually does like equals 1.1 for what matplotlib version you need or whatever. Okay, so it's going to copy that requirements into my container, and it's going to run this command for me. It's going to actually install those requirements for me inside pip. Remember, this is all happening inside my container. And it copies the file and then run that command. Python or Python app.py. Okay. So let's, so first we have to build it because we have to create this image using this Dockerfile. Yes.
A dot in the Dockerfile?
Yes.
The current directory that you run Docker from, or the directory where the Dockerfile is?
That's a good question. I think it's,
I don't know.
I don't know either. That's a good question. I always do that dot, so I always have, it's always one and the same for me, but that's a good thing to explore. Okay, so we're going to build it. Now, I should say that this is only if you're dealing with Docker files and you want to create your own specialized image. If you're just using someone's image from the internet, which is often what you can get away with, then you don't have to deal with this, this building. If you want to create your own image, you have something custom you want to build, or your own app, in this case, I want to install my dependencies, then you have to build it first. Okay, we build it. So these first commands, okay, there you go. So it's literally running pip install, and you can see it all out, but that should all look familiar to you. If you run pip install. Yelling y'all. And so what you can do is after this is done, hopefully soon, is we can actually, if we want to, upload it to Docker Hub. And then anyone can use this at this point. Any server that you're in control of or anyone else you want to share this with, like, hey, look at this cool tool. So that's kind of the life cycle of this, is you build it, you can run it locally, but you can also upload it, and then you can access it from anywhere. And then if someone typed in Docker run demo_2, you get to put your username first. So like Philip BL /demo_2, then it would just download and just work and do all these, just would run this app right away. Okay, so Docker. Okay, so we're still, actually we don't, let's make it interactive, okay. So in this case, I don't have to provide a default or provide what command I want to run, because I provided one to run the app for me. So it's in some development mode on purpose because I wanted you to see the output. Okay, so it's there. So let's now run it. So local host port 5000. Serves me right for not getting to this part.
You need to map your ports.
What's that?
You need to do your ports from your container to your computer.
Yes, thank you. Good call. Okay, yes. And you get extra credit. So one thing, remember, they're isolated. So we have to specify what files can go in and out of this computer. That's with the -v, with volumes. You have to do the same thing with ports. Ports is an identifier for networking. Port 5000. We're going to say, what port on your host computer do you want to bind to on the inside the container? So often, or in this case, I'll just do the same. So I'm going to go to port 5000 on my host computer's local host, and it's going to magically take that connection and put it into the Docker container and have it connect to port 5000 on there. Saved me a lot of trouble. I probably would have been crying up here otherwise. Well, I shouldn't say that yet because it hasn't worked yet. I should have let it go. And that's, okay, it worked. Look at this beautiful web page. Minimal viable product, right? It's got one thing in it, just to upload a file. I'm going to choose this file. Where are you? Oh, dang it, I should have done this before. Where? Okay, classes, sorry. You see all my files. Docker intros. Here. Okay. Upload it, I have to hit submit. So what it's going to do is it's going to, when I hit submit, it's going to, not that you need to know, but here it's going to run this Python function for me. Right there, convert. With any luck, it will work. Nope, not work. There you go. So now we can debug it. Why didn't it work? Okay.
I think you chose your Python file.
Oh, I chose my Python file? Come on. Yes. Why did you guys tell me?
You know what you're doing.
Who knows what? I don't even know what I'm doing. Upload. Sorry, CSV. I just got excited. I saw CSV as the beginning of it. Okay. Ta-da. Oh, dang it. This is the wrong one. I mean, it's fine. It graphed it for you. It's just ugly because it has some extra data in there. Let's go quickly clean that out. So I got a captive audience, right? For some reason, I don't know why this has two values from September, and then the rest are okay. Okay, save that, and then let's run it again. There you go. Got the temperature. Phew. So just, I mean, the application itself doesn't matter. Cool, whatever. We used pandas. We used matplotlib, which we learned about, right? I wasn't there for it, but we learned about it. But the important thing here is that we were able to containerize it, so we didn't actually have to worry about those dependencies. And so I could give any one of you, if you had Docker installed, that either Dockerfile, or I could upload it and then give you the name of the image, and you can just download it and run it right from your computer without having to worry about, oh, wait, what Python version do I have? Do I have, NumPy installed in my pip environment or what? It's all magically kind of works and separate. What's cool is, this is one way of doing it, but it's actually often better to, let me show one more thing. You could copy this, and this is good for kind of deployability, but for development, actually, often what you want to do is say, well, don't copy it all. Let me actually sync up my volume. And this, I should not do this because it's not going to work, right? But directory and then into /app. Let's try that. No, I'm going to have to build it. Build. I've made some changes to it, but notice how it didn't have to reinstall all the pip stuff because it's cached. Really nice. If I had changed a line above the pip stuff, then I'd have to recalculate all of it and rerun it. But anything below it, so each line of this, each non-empty line is actually considered a layer in the Docker image. And so if I had changed anything above here, it would have to recalculate. Even if I change requirements.txt, if I add a new requirement, it would actually know and say, okay, I need to rerun this command because this file has changed. So it's pretty clever in terms of recalculating that. Okay, but since I didn't change any of it, and it was just a really simple command, it will run instantaneously. Okay, run. Okay, yeah, that seems about right. Okay, and because it's in the development mode, Flask has this nice feature where it'll do hot reloading for you. So I can go in here and I can say, I can make changes to my code. And it will automatically reload that for me. So under certain conditions, this is actually very ideal. It's really, once you have this first step running, it's exactly the same as developing locally, but you're developing all in a Docker container. So if you set up your environment right, it actually is, really can't even tell a difference. And so if to prove that it reloaded it, let's resubmit that. And we'll see the printout test, which is what I just added. So there are actually ways to do this where you're not having to, every time you make a change to your code, do Docker build and then Docker run. You just kind of leave it running and it just automatically synchronizes because you're using volume and your Python code's smart enough to reload your code for you on the fly. Okay, any questions on this? Anything anyone wants to see? Should I do, what is it, RF? Delete the whole file system. No, that was ending. I mean, we're kind of done. So if yeah.
You mount a volume read only.
Yes.
So the Docker can't blow it away.
Yes, you can. It's something to the effect of it's like :RO or something like that. I mean, you have to look up documentation.
Yeah.
Essentially,
The point is you can do it.
yes, you can.
Because that seems very dangerous otherwise.
Yes. Yeah, you can set things up to read only and typically want to do something like that. Yeah, I mean, so just in terms of how I use Docker, just in my everyday life, I think it's one thing, it's great for testing. That's something we haven't really connected up with, but a lot of these continuous integration things, what they're doing is running Docker behind the scenes, right? They're taking your code and they're saying, let me put this in a Docker container and then let me execute the commands that they gave me in that YAML file or whatever. That's all happening inside Docker. So actually, it goes really well hand in hand with your continuous integration testing and understanding Docker, because that will kind of help you realize how these things are connected. It's great for working with other people because now I can just say, hey, here's my Docker image, and you can just download it and we don't have to worry about, oh, it worked on my computer, oh, but it's because I'm using Python 3.9 and you're using 3.8, or I have that one special library that you didn't have, so it kind of takes care of that. Yeah, it's great for web apps. I feel like that's the big use case for it, or anywhere where you want to deploy it, lots of different places, something. But I would say it's not a great fit for something where you want tight integration with your operating system or with like the file system, because it can be kind of cumbersome. So like the command line utility, where you're trying to just read any arbitrary file on your operating, on your computer, that isn't usually a good fit. Okay. miss anything before?
It's awesome.
Okay, go learn. I mean, this is just hopefully to whet your appetite, to get you excited to go download some cool Docker images or start developing with it. It's not always the right choice, but definitely think about it when you're trying to figure out what to do and make sure you learn about it. So what's your homework? I don't know. The homework is to install Docker in computer and then just play with it. Okay. Awesome. Thank you, everyone.